In this video, we are going to solve some problems based on rotational dynamics. So we will look at torque calculation. Here we have got a problem. George tightens a bolt on his bicycle with a wrench that is 0.20 meter long. If he pulls perpendicularly, that means the angle is 90, on the end of the wrench with a force of 140 Newton. So we have got the force 140 Newton. How much torque does he apply? We have got the formula. We can substitute the numbers, get the answer and put the unit, which is Newton meter. So our answer here is 28 Newton meter. Do not forget the unit, Newton meter, and also do not forget that if it's perpendicular, that means angle is equal to 90. Next we have got a problem in which it's asking you how to increase the torque on the wrench. Now in the formula Rf sin theta, we can see that torque can be increased if we increase R, or we increase force, or we increase angle. So it says using a longer wrench, that means we are increasing the R, that means that's a possibility. Next one, decreasing the angle, that's not correct because decreasing the angle will decrease the torque. Increasing the force, yes, that's correct. That means 1 and 3 is our answer. Now let's look at some of the other examples for torque. If we have got a rod like this with the pivot and the force as shown, we can see that the distance of the force from the pivot is labeled as R, and the angle between the force and the distance is 90. In this case, the torque will be maximum. The answer which we will get for torque will be the maximum torque. In this diagram, the second diagram, we can see that the force is passing through the pivot. So I have drawn dotted lines to show that the force is going to pass through the pivot. If we have a force passing through the pivot, the torque will be 0. It can also be drawn in these ways. These are the different ways in which the force can be drawn. We can see that in all of them, it's passing through the pivot. That means the torque will be equal to 0. Next, let's look at the calculation for moment of inertia. Moment of inertia we want to find for a toy which is at a distance of 0.7 meter from P. We have the formula for moment of inertia, mr square. M is given to us as 0.6 kg, which we can see here, times 0.7 square. The answer is 0.294, and don't forget the unit, which is kg meter square.